Welcome to the channel Physics Made Easy. In the optics, we are discussing reflection by spherical mirrors. Today we will discuss what are the rules for sign convention. What does it mean? From mirror, the object is kept at certain distance, its image is formed, its focal length, height of object, height of image, with what sign we should represent it. Today we will learn it. First of all, we will see what are sign convention rules, then image formation by convex and concave mirrors. Look, what are sign convention rules? First rule says that all distances are measured from the pole of the mirror. First rule, all distances are measured from pole of the mirror. Okay. Second rule says that the distances measured in the direction, in the direction of incident ray. The distances measured in the direction of incident ray, this is incident, okay, are positive and opposite to that are taken with negative sign. Okay. Okay. Third, height above the principal axis. Height above the principal axis is positive and height below the principal axis is negative. How? Let's see. Suppose I am showing this mirror. Suppose this is the concave mirror. Okay, it is here. This point, as we have discussed, the center point of the size of mirror, then this is pole, midpoint, and the center of curvature, that mirror is a part of glass sphere, that center, whose center is called center of curvature. Suppose this is the center of curvature C, then from center of curvature the line passing, this is called principal axis. Okay. If you place the object here, suppose this is the object AB, you show it here. Then look, all distances are measured from the pole. What does it mean? Suppose its image is formed here at somewhat at this distance. So its image is named at A dash, B dash, and this is the mirror of a small aperture. So midpoint is F, that is PF is the focal length. Learn that all distances are measured from the pole. So if the object is AB, then its distance is represented by U, and from where it is measured, P. Then look, for concave mirror, the distance of object, what will be? Sign of U, positive or negative? Look, the incident ray will come at the mirror in this direction. This will be the incident ray or not? Will be or not? Then you are measuring the distance from the pole. As per the rule, all distances are measured from the pole. So from P to A, distance is measured in this direction, that is in going opposite to the incident ray's direction. So what will be the sign of U? Negative. Similarly, image is also formed. Then what will happen? That the distance of image from the pole, which is represented by the symbol V, then what will be the symbol V, sign of V? You will write here with minus V. Similarly, focal length, what will be here? Minus F. So, for concave mirror, for this distance measurement UVF, what we observe? All these three are negative if the image is formed in front of mirror. Okay. Now, this is the object. These two rules we have seen, all distances are measured from the pole. Okay, we started from here, and distances measured in the direction of incident rays are positive. So, in the direction of incident ray, we have not measured any distance. All distances are measured from the pole, and in the direction opposite to the incident ray are taken with negative sign. So, we have put, because we have measured distance from here P to A in the direction opposite to incident ray, P to C again in the direction opposite to incident ray, and P to F also. Third, height above the principal axis is positive. So, if this object is of height HI, then what will be its sign? Positive. This HIO, okay, and this image is HI, then its sign will be negative. Why? As per third rule. So, in this way, all these three rules you have to remember and apply. Now, we will see image formation by concave mirror. As you know, if you draw the concave mirror, we have in our syllabus the concave mirror of small aperture and a straight one. Remember this. Why? Because all the rays are supposed to be paraxial, that is very near to the pole. So, if I am showing this concave mirror, okay, like this, this is the principal axis, because it is the line which is passing through pole and center of curvature. Midpoint will be F, because mirror is of small aperture, so you will write here F. Okay. First thing, if the object is placed very near to the mirror, that means where? Within pole and focus. So, if you place the object here, this is the name of object, you write here this A, B. What are the rules? That if a ray is parallel to the principal axis, this is the ray from the object, incident ray. After reflection, parallel ray will pass through the focus. You join this point and focus, use your scale, and you join this point and focus to show reflected ray. Now, this ray is reflected from the mirror at from the point of incidence, this point M, okay, and it will pass through focus. What about the second ray? Minimum 2 rays are required to find the image. So, what will you do here? That CP, can you assume CP as principal axis, the line passing through the point P and C, but CP is the radius of curvature, and radius of curvature is supposed to be normal at the mirror. All radii are normal at the circumference. So, you can take another ray from the object at certain angle, it will strike at P, this principal axis. So, at the same angle, because this incident ray is making from normal this angle, and at the same angle it will be reflected as per the rules of reflection. So, at the same angle you reflect this ray. Okay. What will happen? They will diverge on increasing further. In front of mirror they will diverge. Then where will they meet? You have to extend back. So, like this. You have to extend back, take your scale and pencil, and you have to extend back the mirror these rays. Where will they meet? Okay, this is the point where they are meeting, and this will be the virtual image. Why this image is called virtual? Can you tell? This image is called virtual image A dash B dash, because the rays are not actually meeting here to form the image. You have to extend back. So this image, this is A dash B dash. What about the characteristics of image you will write? Enlarged, virtual, inside the mirror. Learn these characteristics. And what question can be asked? Where will you put the object to have erect, upright, enlarged, virtual image from the concave mirror? Then you will answer that object is to be kept very near to the mirror, that is between pole and focus. So this image is virtual. You know the difference between virtual and real image. And upright, erect you can say, and enlarged, bigger. So these are the where behind the mirror or inside the mirror. These are the characteristics of the images. So this, in this way you have to find. Okay. Look, the second position, what I am going to discuss. If you place the object, this is the concave mirror and this is the again same principal axis. Okay, this is C, this is F. Now we are bringing the object far from the mirror, very near to the mirror, that is in between pole and focus. Now at the focus, if you place the object at the focus, what will happen? This is the focal point or this is the object. What will happen? A ray parallel to the principal axis will pass through focus as per its rule. So okay, it is passing through. Similarly, you can take another ray from this object at the pole. It will strike here at the pole and it will reflect from the pole. So this ray is reflected at the same angle. So making same angle from the pole, these two rays will meet, it is said, at infinity. So if the object is placed at focus, the image will be formed at infinity. This image will be real, very large and at infinity. Look, this is the ray diagram. Now we have seen that object was placed first between pole and focus, then at focus. Now where will you put the object? Between focus and center of curvature. Now this is the object as per the first ray. What will you draw here? Again the ray parallel to the principal axis will pass through focus. So you will draw the ray like this. Okay. Same, take the second ray at the some angle and don't forget to mark the arrow. So at the same angle it will be reflected. So this reflected ray will meet here at this point. Okay, this is the reflected ray. So at this point of intersection you will find image. Now look here, this is real image. Why? Because the rays are actually meeting here. So this object, its image is inverted. What are the characteristics of this image? Real, inverted, enlarged, in front of mirror. So in this way you have to write the characteristics and you have to draw the ray diagrams. Next, from between F and C, we have seen enlarged image. If you bring the object further away from the mirror, then you will have to keep the object at C. Okay. Remember, the object is at C, then its image is also at C. You will see here, and if you already marked the same distance point here, that if this is the object and this is the image, you draw the image like this. Okay, you mark the point. If you don't draw, first you mark the point so that the size of image and size of object is almost already same you have drawn. And how will you show? Same. If you take the ray parallel to the principal axis, then from these 3 points it will pass through focus and it should pass through this point also. So you have to draw. Take your scale pencil this way, and another ray which is coming at the certain angle with P, and it will pass through this point. This is, you have to join with the scale. So this ray is reflected like this, so that here again you are getting real image, okay, inverted. I am not writing in each case. Here it is enlarged, here of the same size as the object, okay, and in front of mirror. All 4 categories here: in front of mirror, enlarged, real, inverted. Here real of the same size as the object, inverted, and in front of mirror. Similarly, if you place the object beyond C, look, I am shifting the object away from the mirror. Then what will you find? If this is the object, then again the ray parallel to the principal axis will pass through focus. After reflection, it will pass through focus like this. Okay. Now, what will happen? That another ray you will take, then this is incident ray, this is reflected ray. You will find that if a ray is here at certain angle from the pole, this one, then this incident ray is reflected at the same angle, then this is the reflected ray. You will find that this is the image. So this AB object, its image is A dash B dash. Here this AB object is image is A dash B dash. These two are said to be conjugate position. How? Look, object is in between F and C, image beyond C. It's reverse. Object is beyond C, image is in between F and C. What is the difference? Here the image is diminished, of the smaller size than the object. What here? Image is enlarged, bigger than the size of the object. Rest of the things, in front of mirror, here inverted real, here also in front of mirror, real and inverted. So in this way you have to draw the figure. Now where will you keep the object? Finally, at infinity. Infinity, what do you mean by infinity? As compared to the radii of curvature or focal length of the mirror, the distance of the object is very, very large. So it is said that object is at infinity. And the incident rays are coming from infinity, then they are parallel. So if the object is at infinity, in this case, so the rays will come from infinity, and after reflection from mirror they will pass through focus. Again this is the ray which is coming from infinity, and after the reflection through mirror it will pass through focus. So at the focus, real diminished image in front of mirror at the focus is formed. You will find no, here you are not looking the image. how can you say that you are saying that real is real image, inverted image and diminished? Because we have seen that if from the C position, suppose if you shift the object, what will you find? That this angle from, suppose at this point here, if we keep the object here, okay, at this point, then one ray will pass through the will parallel to the principal axis, pass through the focus. The other ray will pass, suppose this way, and it will be reflected in such a way that this image is obtained. If you shift the object here, okay, you are making the object away from the mirror, then what will happen? This angle from this ray will pass through the focus after reflection. This will be the incident ray here from this case, second case, okay. But the other ray will come at the smaller angle, suppose this one is, okay, and this ray I am making with two arrows, and it will be reflected. Then what will you find? These two arrow ray, this will be the image here, okay. This will be diminished one or not? I am making with two arrows. The object is shifted away, then the image is shifting towards F. Look, if I will further shift the object, okay, if I will further shift the object, then can you imagine that the ray will be reflected from the focus, the first ray which is supposed to be parallel to the principal axis, but the other ray that will make a very little angle, and again you will find that this triple arrow ray, it will be very complicated to look here, is reflected, and this is a very little object will be obtained at focus. That's why how to draw the figure that if the object is at focus, then where will be the image? If the object is at infinity, then where will be the image? We simply take the parallel rays which are coming from the object, and we draw the parallel rays at the mirror, okay. This is the principal axis, this is P, this is C, this is F. Then we take the parallel rays, and this is reflected here, parallel ray, and it is reflected. So both the rays are passing through F, and here F, highly diminished real inverted image is obtained. Now for convex mirror, you know convex mirror is drawn like this. Its reflection from this mirror takes place from the bulging side. And how is the principal axis drawn? This is the pole, again the midpoint of the mirror, and the center of curvature, this is C, the radius of curvature, this CP, or any other point from C to the mirror, that is the radius of curvature. How the sign convention rules? As per sign convention rules, what will be the image, object and focal length direction? Look here, if you put the object here, then height of object is above the principal axis, so this HO will be positive. Third rule we have discussed. And what about the image? So if this is the convex lens, and the object, from the object incident ray travels like this, okay, it falls at the mirror at point M. This is called point of incidence, okay. All the distances are measured from the pole, and the distances measured in the direction of incident ray are positive. Here from the pole, if you see the distance of the height, this object is represented by u, then you are measuring the distance from pole against the incident ray, so it will be negative. Here in between P and C for a small aperture mirror, this will be F. Put this arrow. PF is the focal length of convex mirror. Which sign? Look, you will measure from P to F. You will measure focal length here in this direction. That's why F is with positive sign. So, why the concave mirrors have negative F and convex mirror positive? Due to sign convention rule. Okay. What the image? So, I will discuss how the images are formed. Here in case of convex mirror, you put the object anywhere. The image is always formed between pole and focus or at the in between P and F points. Look, I have shown here this AB is the object in this same figure. Okay. The ray is incident at point M. Okay. What is this M point called? Point of incidence. What will you do to draw the reflected ray? Look, you will join C with M and what will be this point, this line CM, or you write here N. Okay, this will be the normal at the mirror. So, what will be this angle? Angle of incidence. Same will be angle of reflection. So, taking the same angle, you will draw this is the reflected ray. And if this reflected ray is extended back, if you have measured correctly these two distances, look what I have shown, it will pass through focus. So, parallel to the principal axis, if the incident ray is there, then it is reflected in such a way that on extended back, it appears to pass through focus. That's why focus of convex lens is virtual. What about concave lens we have seen? Okay, I am going to compare again that if this is P, this is F, this is C, and if we have placed the object in front of concave lens, suppose here, then the parallel to the principal axis ray, it really passes through focus. That's why this is real focus, and its focal length is measured in the direction opposite to the incident ray. So, its focal length is negative. What here? Its focal length is positive because this focal length is in the direction of incident ray. Now, what will happen to find the image formation? So, one ray is reflected. Okay, it is parallel to the principal axis, so it is reflected and it appears to pass through focus. What about the other ray? If you see the other ray, you know the rule. If you take a ray coming from the object in the direction of C, this point, center of curvature, what will happen? You take the scale and you draw a ray that it comes in the direction of C. So, it's better to join this B and C with the scale and then you will mark. Okay, I am joining like this. This is coming from C, suppose this is. So, this will be the normal ray. Why? Because C and this point, again it will be the radius of curvature, so it will be normal at this point. So, normal ray retraces its path. Why? Because angle of incidence will be 0, angle of reflection will be 0. Listen again, for this ray, this is the normal, this is the incident ray. So, same will be the reflected ray. So, on extending back, if it is coming here, it will pass through C, only then it is supposed to be normal. Then at the point of intersection, you will get image which is diminished. Diminished means smaller than the size of object. This will be A dash, B dash. Okay, A dash, B dash, and between pole and focus, and behind the mirror. What will be its distance? Image distance is represented by V. So if you see that what will be the image distance from pole to this distance, this will be V positive, V with positive sign, okay, and pole to focus, this one, this F is positive, we have discussed earlier. So whatever is the position of object in front of this mirror, the image is diminished behind the mirror between pole and focus, okay. In this way you have to find the image. Now we have seen from the plane mirror, image is always of the same size as that of the object and virtual. From convex mirror, always diminished, that is smaller than the size of the object, and again virtual. This image is virtual, diminished, okay. What from concave mirror? Only one case where the enlarged and virtual image is seen. That's why concave mirrors are used in shaving and beauty parlors. So enlarged and bigger image, concave mirror, virtual, enlarged, upright and bigger image from concave mirror, and from convex mirror, diminished, virtual, and from plane mirror, of the same size as that of the object. Rest of the real images are only formed by concave mirrors. So today I hope you must have enjoyed. Thank you.